So this Jupyter Notebook, it shows you how you can compress an image using PCA. I'm going to compress an image that shows digit 3, and then I'm going to decompress that image. So first thing you want to do is import your necessary libraries. I'm importing my NumPy, importing my Matplotlib, and also importing my from my sklearn, importing PCA. Okay, so let's run this cell first. Come down. Then my image is mnestimage3.png. This is the image I'm using. So let me show you that picture. So this is that image right here, image 3. Let me just double click and show you. So this is my image 3, and you can see the dimension of this image is 28 by 28 pixel. You can see that right here. Let me move this in the center. Right here, dimensions 28 by 28. Okay, then I load my image. I convert my image into NumPy array, and then I'm printing this image. So if I scroll down, you can see there the outline of this image is almost 3. Let me decrease the size of screen a little bit so you can see the whole image. There you go. So this is the data, and in this data there are 784 values. And this, you can see the outline right here from here all the way up to here. This is like, these are finite numbers. The rest of the numbers are all 0. Now, the numbers on these pixels, they are going to be between 0 to 255. 0, it refers to black, and 255 refers to white. Any number in between, that would represent the level or the intensity of whiteness. So for example, 212 represents that it on a scale of 0 to 255, this is white on a scale of 212. Okay, coming down now. So let me just increase the size of the screen. Then I'm plotting my image this time. I'm plotting using Matplotlib. So you can see that it is 3. So step 1. First thing we do is standardize our data. Now all our numbers, if you look over here, they're all in the range of 0 to 255. I do not want that. You want to have your numbers in a smaller scale. So in this case, I'm scaling it to 0 to 1. So this way I'm dividing by 255. Now we find the variance of each principal component. So in this case, I'm picking 20 component, and I'm printing my explained variance ratio. So these are my numbers. So the first one tells me that first principal component, it contains 47.7% of the variance. Second principal component has 26.9% of the variance. Third principal component is contains 11.3% of the variance, and so on and so forth right here. Okay, now I want to see these numbers visually. I want to do a bar plot. So I'm plotting my bar plot right here. I'm actually using in PLT library, I'm using bar inbuilt method, and I'm putting my necessary inbuilt parameters in here. Then I'm giving some title, putting my X labels, and come down here, and you can see the variance explained by each principal component. So this is my number 1, number 2, number 3, number 4. And you can see the most variance is contained in the first 3, 4 of them. Okay, now I want to do the cumulative sum. So in this case, I'm actually plotting cumulative sum, and I'm also printing the cumulative sum values. So here you can see the first, the number 1 variance, or number 1 principal component explains about 44%. It tells you right, 47%, sorry. Then the first 2 explains 74.6% of your variance. That would be this number. And the first 3, that would be number 3 right here. So the first 3 will explain 85.9, and the first 4, in other words, principal component number 1, 2, 3, 4, all taken together, will explain 92.3% of the variance. So you can keep going like this, and you can see that 10 right there is almost like very close to 100%. So 10 would be somewhere, I think, this number right here. Okay, so in this step, now you identify the number of components you need. So 10 components seems to be a good number. So it explains 99% of your variance. So I'm picking up 10 components, I'm applying my PCA to that, and I'm also printing the dimension of my shape, and I'm also looking at the compressed shape. I want to see, after I apply my PCA, how does my image looks like. And look at this, now it's 28 by 28. Compressed shape now is 28 comma 10 right here. Okay, I'm also looking at the size of my image. So you can see the size of my original image is 6,272 bytes and the compressed data size is 2,240 bytes. You can reconstruct your image now from the PCA. So I'm taking my compressed image, which is this right here. Okay, and actually, right, no, sorry, not this one right here. Compressed image that was created using PCA. So I'm reconstructing my original image right here, and I'm printing my shape, and I'm also printing the size of that image. And as you can see, it's 28 by 28, and you get the same size. You get the same original size. Now I want to compare my original image with the image that is reconstructed using PCA. Now remember, you actually went from like high dimension to low dimension, then back to high dimension. So there was some loss of information. So let's try to see how much information was lost. So in this case, I'm plotting my original image right here, and then I'm also plotting my reconstructed image. And I'm also plotting a heat map. So this is the image. This is my original image, and you can see this is 3, and this is the one that's reconstructed after you have applied PCA. And you can see it pretty much looks like 3 right there, okay? And this one has 10 components. And this heat map tells you the difference between this and this image. So if you see white, white basically means that there was a large difference, and black means there was pretty much no difference. The red in between, this indicates there was a moderate amount of difference at those pixels. So now I now I come back and I change my number of components from 10. Let's say I make it like just 3. And let's run this cell and come down, or let's just see what is the size to. And look at the size is 672 bytes, okay. And reconstructed image, okay. Come down, plot this image again. And now let's see the difference. You can see there's a lot of information lost because you went from like high dimension to a low dimension, and you went very low this time. So there was a lot of information lost. So the more number of PCA that you have, the more information you're going to have. And if you do less PCA, you're going to lose some information. Okay, and let's go back over there again. Let's change this to now maybe, let's make it 20 this time. Let's just go back to 10. Yeah. 10, run this, come down, run this again, and reconstruct the image again, then come down and let's plot this image again. And now you can see it's pretty much same. So these two images, they look very identical. So I hope this session helps. Thank you.